moving on, and want to make sure that you got this under control. So these are not in your notes. These are 2 extra problems. I'm going to do my paper, not do them at all, I don't care. But like a linear function given these data points. So we know that this is the ordered pair 2, 3, and this is the ordered pair -1, 12, right? Linear, line, slope. So m equals 12 minus 3 over -1 minus 2. So that's going to end up equaling -3. Then I pick my point. These are extra ones I'm just doing to make sure we're all on the same page. So I'll pick a point. I'll just use that one. It doesn't matter. So y minus 3 equals -3, x minus 2. Now that would be fine, except it does say linear function. So I'm going to get y by itself. So my linear function is going to be -3x plus 9. Is that okay with everybody?
I was on lunch duty.
They should have sent you the past then.
It said the email.
Okay, they will email me then. Okay, and then stay off lunch duty.
I know, yeah.
Okay, everybody okay with that one? Okay, next, find the vertex form. Now, once we have the vertex form, we'll be able to find the vertex, axis of symmetry, and direction of opening, right? The issue is, can you get this thing into vertex form? So, what do we do?
Get 2, put the 2 over.
First, you gotta move the 2. It's possible to do the problem with the 2 still there, but that makes it more complicated, I think. So just move it to the other side. And now, take out the -3, because you are going to complete the square. Let's see, that's going to be x squared minus 4x.
4.
And always make sure that if you distribute, you get that number, which I do. So, half of 4 is 2 squared is 4. Put a 4 here. Now, you have known since Algebra 1 that if you add something on the right, you got to add it on the left. That's true. But you got to add the same thing. So it looks like you're adding a 4, but you're not really adding a 4. You're really adding a -12. So that's what has to go over here. The thing you actually added over there, which is -12, has to be added over here also. So y minus 10, what's my square here? X minus 2. So my vertex form is y equals -3 x minus 2 squared plus 10. So from there we could say our vertex is 2, 10. Axis of symmetry is x equals 2. And the direction of opening is down. Okay? All right. Now, problem 5 is just like what we just did, except you're asked to do the problem a different way. You're asked to find all the vertex and all that using the axis of symmetry formula. Anybody happen to remember that from last year? Yeah, actually the axis of symmetry formula is x equals -b over 2a. And the b and the a are the same as they are in the quadratic formula. So this would be a, C. Alright? So, axis of symmetry is gonna be x equals negative b over 2a. So my axis of symmetry is x equals 2. Now, remember, if my axis of symmetry is x equals 2, then isn't the x coordinate of my vertex 2?
Yes.
But I still need the y. How would I find the y coordinate?
Plug it.
Plug into. Plug into.
What?
Jake, negative b over 2a. There's b, there's a. What's 2 times negative 4?
It's not a student.
Alright, so I'm gonna plug in 2. So what do I get when I plug in 2? 2 squared is
4, negative
4,
16.
so that's gonna be negative 16
What's 32?
minus 32, or plus 32, plus 3,
Yep. 19.
19. And then which way does it open? That's easy, it opens down. So you can find that stuff we were looking for without altering the equation if you remember your formula. Alright, let's try this one. What is my axis of symmetry going to be? Negative b
6
over 2/3, 2 times 1/3. Yeah. Stop talking, we got it, we're okay to this point?
8, it's gonna be 9.
Now remember, that means 6 divided by 2/3, which is 6 times 3 halves, which is 18 halves, or 9. So my axis is x equals 9, which means my vertex is 9 comma. And then I'll plug in that, so what's 9 squared? And 1/3 of 81 is 27, minus 54 plus 1. So negative 26. And this one opens up. The axis of symmetry formula can be so helpful in some problems, depending on the numbers in the problem. So it's really a good idea to know that. Keep that in your back pocket. Okay? All right. Now we're going to do this backwards. So somebody has figured out that we have a parabola. The vertex is 2, negative 3, and it contains the point 1, 5. Now, what that means is, don't be confused by that vocabulary. Here's my vertex, and here's the point 1, 5. So the parabola goes through that point. So this is what my parabola looks like. And your job is to write its equation. Now there are different ways you can write the equation. Is this one way to write the equation of a parabola?
Yes.
Yeah, that's fine. But given that I know the vertex, maybe I'll write this one in vertex form. Now remember, this is what vertex form looks like. I'm making this up, I'm just making up this problem. But that's what vertex form looks like, right?
Yeah.
And what goes here and here?
The vertex.
The vertex. So I know from what I got here that I'm gonna have y equals something, I don't know what, I'll call it A, I don't know what that is. X minus 2 squared minus 3? Would you agree with that? So basically I have my equation, except I don't know this number.
Yeah.
Alright, but wait a second. That's an X and a Y, right? I plug it in, if I plug in my X and my Y, will I be able to figure out my A?
Yeah.
That's what I'm gonna do. So I'm gonna go ahead and plug in that random point. Speaking of random point, remember, if you're doing it this way, the point you use has to be the vertex. Right? Don't be putting the 1 and the 5 in here to build the equation. It has to be the vertex that you start with. Then put in 5 for Y and 2 for X. Oh wait, 1 for X. So I put 5 in here and 1 in here. Alright, so here we go. 5 equals, what's 1 minus 2?
Negative 1.
Squared.
1.
So this is just A minus 3. So it looks like my missing number is 8.
Yeah.
And there's,
Where that
sorry.
one goes?
The 1 was with the S.
Alright, let's try another one, same thing. This time the vertex is 5 1, and we contain the point 0, negative 2. It says write the equation, so it would be okay. If it said quadratic function, then I would have to have it. But it's the same thing, right? One. Okay. What's our starting point going to be? Y equals
A.
something, x minus 5 squared, plus 1?
Yes, ma'am.
Then we'll put in negative 2 and 0, and make sure, guys, you're putting in x and y in the right spot. So negative 2 equals PEMDAS, parentheses first,
Negative,
so that's negative 5 squared is 25, so it's 25a plus 1. Do not add 25 and 1, because that's 25a.
minus the 1 is
So
always.
minus the 1 and divided. So then our final answer is the equation we had, only we'll put in negative 3/25 for our A. Alright. There's one more. Do I have a volunteer who would be willing to come up
What?
and give
I'll do it. No.
this last one a shot? You do it over here, Dan.
Go get him, Tiger.
Jack Lockhart, what are you doing? What are you doing? Get your pencil moving on the paper. Let's go.
You don't see it?
I agreed with Dana. Do you agree with Dana?
Yeah.
A is 4 nines. Anybody have any question about Dana's work? These are really easy, but I will tell you, having graded lots of these over the years, that for some reason, sometimes we get these in the wrong spot. The vertex is always what goes in first. The vertex is how you start building your equation. And then you plug in. All right, we okay? All right, get out your little word problem sheet I gave you, that page of word problems. And we're gonna start on page 184. So one of the pages is page 184. And we're gonna look at problem A. 54, page 184, 54 is A. So we're gonna start with problem 54. All right, so let's see what's happening. Among all the rectangles whose perimeters are 100, find the dimensions of the one with maximum area. So we have a rectangle, and we know its perimeter is 100. So how long are the sides? Well, if it's a square, they'd be 25, but do I know it's a square? So could they be something different than that? All right, so I'll call this X. What do you want to call that?
2X.
Does it have to be twice the width? I think it could be, but I don't know that it is. What do they all add up to, you guys? All the sides?
100.
All the sides add up to 100. So what do these two add up to? 50? So if this one's X, this one would be 50 minus X,
Yeah.
right? If the whole thing is 100, we know one width and one length then would have to be 50.
Yeah.
So if I call one of them X, the other one is whatever 50 minus X is. So if this is 10, that's 40. Does that make sense to you?
Yeah.
Now, what's the area of this rectangle then? X times 50 minus X?
Yeah.
So Y equals negative X squared plus 50X if I put it in descending order.
Yeah.
Is that okay with everyone? What shape is that? Parabola opening down. And the question asks about the maximum. What would the maximum be?
50.
Well, the maximum would be the vertex, wouldn't it?
Yeah.
Wouldn't it be the vertex? So do I know how to find the vertex of this?
Yeah. You go for it. It's square.
I can complete the square, or I can use negative b over 2a. Either way is fine. You can complete the square. If you do that, you gotta factor out the negative, -1. Or you can just do x equals negative b over 2a. Which means my maximum x value is 25. Which means this side would also be 25. Some of you guessed that, but you really were guessing. But you guessed right. Which means the maximum area will be what?
625.
625. So your job was to find the, oh, we're just finding the dimensions. So the dimensions are 25 by 25. If your equation is a parabola, x squared, then anytime you want max or min, you're just looking for the vertex. That's it, just find the vertex of it. Okay, next we have 57. Julie has a patio, and her patio is 25 by 40. The patio is surrounded by a terraced strip of uniform width, in case you wonder, planted with small trees and shrubs. So here is the trees and shrubs are here. And the area of the green is 504. Find the width of the strip. So this right here is the width of the strip. Does that make sense to everybody? Are you following my picture?
Oh, we have a picture too.
Oh, is there already a picture there?
Yeah.
Okay, we'll bring it here. Okay,
So we have to subtract.
now, do we know the area of the original patio?
Yes.
We could certainly figure it out. What's 25 times 40?
1,000.
1,000. So this area is 1,000. And the area of the strip is 504. So would you agree with me if I said the area of the whole thing is 1,504?
Yep.
Now, the whole thing is a rectangle, right? So if I knew what this and this were, if I multiply them together, I should get 1,504. Agreed? Okay, so what's this? No, this dimension right here. What's this green line right here? How long is that? 25 plus 2x. Because you didn't add one at the top and the bottom. This is just like the box problem. Only like the box problem, we were cutting it out. Now we're adding it on. So this is 25 plus 2x.
And then 40 plus 2.
And that one will be 40 plus 2x.
And you combine.
Now, can I multiply this out?
Yeah.
Move this over and get it set equal to 0, right? Be careful, does this say anything about max or min? No, I'm not looking for vertex, I'm solving it. So if I'm solving it, I want it set equal to 0, all right? So let's see, you said that was 1,000, plus 50, plus 80, plus 4x squared. Darn, well, we'll pick up here tomorrow. Let's finish that problem up and move on. Have a wonderful rest of the day. And I will see you tomorrow.
Yeah, he was G-Cut.
It's kind of your side, Jed.
Let's see.
Bet on myself.
No, ask them to email me. Wow.
will, I'll email you.
See why this kid.